welcome back everyone. I hope everyone's doing great, and let's get going. Alright, so last time we talked about what a limiting reactant was, and I asked you to, if you can, to do this and upload some pictures on that Google slide. Some of you weren't able to do that, but you went ahead and submitted some descriptions of alternate examples of limiting reactant. Thank you for that. So we talked about what a limiting reactant was. Remember, it's the reactant, not the product. It's the reactant that runs out first, okay, that determines how much product you can make. Okay, determines the amount of product. It's the reactant that runs out first. Okay, or runs out. So our next assignment, I asked you to take a look at this, and if you could, to do a Google Meet with a couple other people and work through this together. So hopefully you've attempted that, and now you're watching this video to see if you got it right. So I'm going to go through this with you, and the reason I'm having you do this is to get you ready to do the calculations and to understand the process behind it while you're going to take the steps that you will be taking. Okay, so what you should have done is write the balanced equation for this, and I didn't give it to you because these are fairly easy and I think you should be able to do the easy ones. Okay, so write a balanced equation for the reaction between hydrogen and oxygen to make water. So we're reacting hydrogen and oxygen to make water. However, hopefully you remember that these elements are diatomic and you needed to put a 2 there. Okay, so that's going to affect your balancing, your coefficients, right? To make sure that you have the right formulas before you go about balancing. All right, so if you didn't get that right, then make sure you fix it. All right, and then to balance this, we have 2 oxygens here. We only have 1 there, so we've got to put a 2 in front of this, which gives us 2 oxygens, but also 4 hydrogens. So we're going to have to put a 2 in front of that. Okay, and then it says, suppose that 4 molecules of hydrogen gas and 4 molecules of oxygen gas react to form water. So some of you may be confused because you looked at this and said, well, it says that 2 of these are going to react with 1 of those. No, this is the recipe. This is how they're going to react. For every one of these, you need 2 of those. But doesn't mean that you're going to start out with that. You can start out with other amounts, but what's going to end up happening is you're going to run out of one of them as you're making product. Okay, so remember, this is the limiting reactant that we're studying. So what you should have done next, let me zoom. Let me lock this focus here so it doesn't keep doing that. Okay, all right, so you should have drawn 4 molecules of hydrogen. So remember, they're diatomic. So I'm going to draw 4 of these. Okay, those are my 4 hydrogen molecules that they're asking for. And then 4 molecules of oxygen. So oxygen, I'm going to draw like that. I'm going to have 4 of these. Okay, 2 oxygen atoms bonded together. And this is the before picture before it becomes water, and now it's going to become water. So we're going to use our starting material to make our water. So water is 1 oxygen and 2 hydrogens, right? So we use 1 of these and 2 of those. Okay, we're going to do another one. So I use 1 of those and 2 of these. Use 1 of those, 2 of these. Okay, 1 of those, 2 of these, and then I don't have any more hydrogen, so I can't make any more water. So my after picture is going to have 4 of these water molecules, but it's going to have these 2 unused oxygen molecules. Okay, these bigger. Okay, so this is the before picture, before the reaction happens. That's the after picture. So how many molecules of water can be produced? with the starting material? 4. And which reactant is in excess? Oh, what's left over? Oxygen, right? We had too much oxygen here for this ratio of reactants. So I have 2 of these. Why is that the excess? Because oxygen did not get used, or you could have written ran out of hydrogen. Either one of those be fine. How many molecules of excess reactant are there? 2. Okay, so let's now draw the do the VCA chart. So this is it conceptually. What does it look like if I didn't want to draw the picture every time, which is going to be the case? So we're going to write out our balanced equation. Right, you have to have the balanced equation to do stoichiometry. Okay, and our before pictures, we had 4 of each, and none of this. Okay, and then our after, or the changes, we used up all 4 of the hydrogen, right, -4. And then if we used up all 4 of this, based on the coefficients here, I should only have used 2 of these. Okay, and is that correct? Yes, I only used 2 of those. Okay, so when you're doing this without drawing, you're gonna to figure out your limiting reactant, you're gonna use up one of them, and then you're gonna see how much, according to the balanced equation, your ratio here, how much of the other reactant you're gonna use up. And if it's less than that, then you know this is the right limiting reactant. Okay, but let's say we did this instead. I'm going to cover this up. Let's say you didn't draw the picture and you didn't know which one was the limiting reactant. Let's say you thought, okay, I'm going to choose this. If I used up all of my oxygen, then based on my ratios here, how much hydrogen should I have used up? And that would have been 8, right? And we can see that we can't use 8 because we only have 4 here. So this is not the right reactant that's going to be the limiting reactant. So then you choose the other one. Okay, so we used up all 4 here, 0, and this is we have leftover now. We have 2. Oh, I don't need to put 2 there. Plus there. We have 2 leftover oxygens. I made 4 of these. And I have 4 at the end. Okay, so according to the table you just made, how many molecules of water can be produced? 4. Which reactant is in excess? 2. We can see it there. Okay, did not use up all available oxygen. Okay, and how many molecules of excess reactant are there? 2. All right, so based on your 2 methods of analysis above, what determines how much product can be made from a particular reactant mix? So I want you to answer this question. Oh, wait. Oh, I didn't highlight that one. Okay, never mind. I'll answer it. Based on your 2 methods of analysis, what determines how much product can be made from the particular reactant mix? And that is the amount of limiting reactant. Okay, so if we look back up here, we're not going to use this to figure out how much product we're going to make, right? If we use this, then according to the ratio, this should be 8. So we're not going to use the excess amount to figure out how much. Okay, we're going to use the limiting reactants amount. So in our mole ratio, we're going to use this amount as our starting amount, and then use the ratio, 2-to-2 ratio, to figure out how much of your product you're going to make. Okay, so what determines the amount of product? The limiting reactant. Okay, so go ahead and write a summary and reflection of this. I'm going to quit the video, and then you do number 2 before you watch the next video.